This lesson will introduce you to sampling distributions. Sampling distributions are the foundation of statistical inference when data are produced by random sampling. Because there is natural variability between samples, we need to know how close the sample value is likely to be to the population value that we seek to know. The predictable behavior of sampling distributions allows us to answer that question. We'll start with a review of some vocabulary and notation that you've already seen. A statistic is a number that describes some characteristic of a sample, while a parameter is a number that describes some characteristic of a population. You can remember which is which by the first letter. Statistic begins with S, as does sample, and parameter and population both begin with the letter P. Now, also, the notation is different. So when you're looking at a sample, X bar refers to the sample mean, and that estimates mu, the population mean. P hat represents the sample proportion, and that estimates P, the population proportion. And finally, S, or S sub x, which is the sample standard deviation, estimates sigma, the population standard deviation. For example, here we're going to identify the population, the parameter, the sample, and the statistic. A high school student was interested in finding the mean annual tuition at a 4-year U.S. college. The student randomly selected 23 U.S. colleges and found the mean annual tuition was $19,800. So in this case, the population, what the student is trying to learn about, is all 4-year colleges in the U.S. The parameter that they're interested in is mu, the mean annual tuition for all 4-year U.S. colleges. The sample they took was the 23 U.S. colleges they selected randomly, and X bar was the statistic, and that's the mean annual tuition from the sample. It was $19,800. All right, here's another one. During World War II, the United States captured several tanks from the German army. Based on the serial numbers on the tanks, statisticians estimated that the German army produced 7,168 tanks during the war. So what's the population? Well, the United States was interested in all the German tanks produced during World War II. That was their population. The parameter that they were trying to find out about was the true total number of German tanks. They took a sample, which was the tanks that they captured, and they estimated the statistic as X equals 7,168 based on their sample. Now, just as a tip, on the AP Statistics exam, many people lose credit because they fail to make a distinction between parameters and statistics. For example, in a significance test, which is something we'll be getting to soon, stating hypotheses in terms of statistics instead of parameters will always lose credit. Likewise, if you have to define a parameter, it's important that you use a phrase like population mean or true mean rather than simply saying mean, because mean could refer to the mean of the population or the mean of the sample. They want to know you know the difference. So I recommend that when defining a parameter, use the word all in your description to make it clear you're not referring to the sample statistic. For example, mu, if you're defining mu, is the mean date of all pennies in the bowl. Or P is the proportion of all pennies in circulation that were minted in the 2000s. By using the word all, it's clear you mean the population and not the sample. All right, so what's the idea of sampling distributions? In my classroom, I have a big bowl. It's actually a speech trophy that we earned many years ago, and it's filled with pennies. I have tossed pennies into that bowl for more than 20 years. I'm guessing there are at least 2,000 pennies in that bowl, maybe more. I'd like to know the mean date of those pennies. If we were in person, I could ask each of you to randomly select 5 pennies from the bowl and average their dates to help me get an estimate. But we're not in my classroom right now, so we can't do it. We're going to look at some data on Friday, and when you're finished listening to this lecture, there's a Class Kick activity where you'll collect some data that we're going to use. Please finish that by the end of the day today. I'm going to need some time to compile all that data so that it will be in a form we can use on Friday. But let's suppose there were 50 people in my room and they did find the means of random samples of 5 pennies. If I plotted that data, it might look something like this. So this is just an example of what it might look like if 50 students each took 5 randomly selected pennies out of the bowl, looked at their dates and averaged them. So here it is again, same graph, and it's showing a plot of one possible distribution of 50 samples of 5 pennies. Note that X bar is the random variable. That's the thing that we're trying to find, the mean. And that's why there are little X bars all in that graph. Now, there's going to be variability from sample to sample, and that's why you see some from 1991 and some from 2010 and some from 2001. There's variability. Each of the samples is likely to produce a different mean. And remember, that basic fact is called sampling variability. You're not doing anything wrong if you don't get the true mean. It's just each sample is going to be slightly different from other samples, and therefore you'll get different means. The graph that we're looking at is not an actual sampling distribution, but it is an approximation of a sampling distribution. An actual sampling distribution of a statistic is the distribution of values taken on by the statistic in all possible samples of the same size from the population. In this case, that size is 5. If there were 2,000 pennies in that bowl, then there would be 2,000 C5, or approximately 2.65 times 10 to the 14th possible samples of size 5. Obviously, we're not going to be able to get them all. But if we could, and we plotted all 2.65 times 10 to the 14 combinations of 5 pennies from the population, that would be the sampling distribution. So the sampling distribution is something theoretical. We can actually create it just because of the magnitude of the number of possible samples there are. Now, there's some terminology we use when we're talking about variability. Sampling variability refers to the fact that different random samples of the same size from the same population will produce different values of a statistic. The sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the population. In general, the larger the sample size, the less variable the sampling distribution of statistics will be. We'll explore that further a little bit later. Now, there are different kinds of distributions we look at, and I'm going to take a moment now just to talk about the names because people sometimes get them confused. The population distribution gives the values of the variable for all individuals in the population. In the case of the pennies, if I took all 2,000 pennies in my bowl and made a plot out of each of their ages, like the dates on them, that would be the population distribution. The distribution of sample data, sometimes called the sample distribution, shows the values of the variable for an individual sample. So if my sample only has 5 pennies in it, there would only be 5 dots on my plot. That would be the distribution of sample data. The sampling distribution, on the other hand, the sampling distribution of the sample displays the values of the desired statistic for all possible samples of the same size. So a sample distribution, the second one, distribution of sample data, is going to be one sample of size n, whereas the sampling distribution takes all possible samples of the same size and plots them. Note that a sampling distribution and a sample distribution are not the same thing. You have to be very careful when you use the words in your responses. Also, never just say the distribution, because they could be different kinds of distributions. So you're going to always say the distribution of whatever it is you're talking about. Be careful to distinguish the distribution of the population, the distribution of the sample data, and the sampling distribution of statistics. Likewise, don't use ambiguous terms like sample distribution or sample data, because that could refer to the distribution of the sample data or the sampling distribution of a statistic. If you're not clear, they will assume you don't really know what you're talking about and that you're trying to be vague, hoping for the best. Don't be vague. All right, so at this point, I want you to log on to Classkick, and you will find an exercise called 7.1 Day 1 Exploration. There's one problem to do, a 3-minute video you can listen to that will explain how to answer that question after you've done it, and then some data collection that I would like you to do. You're going to need to find 20 randomly selected pennies from your household to use. So that may take you a few minutes to go run around your house and find some pennies. But see what you can do and collect the data. Please complete that by the end of the day today, so I have some time to compile it so we can use it on Friday. That's it for the lecture. Have a wonderful day.